Okay, trigonometry students, open your notes to 3.2a, the law of cosines. We use the law of sines. It's time to use cosines. And as you label things here as, let's do A, B, and C, side A, side B, side C. There becomes a problem. As you read, it says many triangles are not right triangles, but rather oblique triangles. We know that. We're not able to use the law of sines to solve most triangles. We are able to use the law of sines to solve most triangles. What about triangles where we're given all three sides? Or what about triangles where we are not given the opposite side? Remember, the law of sines requires an angle and its opposite side. What if you don't have an angle and its opposite side? Well, let's use what we know about right triangle trig to derive a way to solve oblique triangles. That's a little bit different. This is how the law of cosines comes about. Now, you'll never have to reduplicate this, but I want you guys to be able to see this. I want you to be able to appreciate where the law of cosines comes from. It doesn't come out of thin air. It has a purpose. And the first thing we do is we draw a height. We draw a height. We'll call it H, and it divides up that one side into you see C here. Side C is the entire length, but I'm going to divide it up into two pieces. You guys have seen this before. We're going to call it X. We're also going to call it C minus X, so that if you add the two sides together, you come up with the entire length of C. Well, we could say a lot of interesting things about this, but what we want to do is we want to be able to convey a relationship between some of the pieces. And I'm going to start with, using these sides down here, understanding these are right triangles that are formed. Using cosine. Cosine involves these adjacent sides as an x and c minus x. We may not see the reason right now, but I'm actually going to set this up using the Pythagorean Theorem. If you were to write the relationship between Bx and H, Bx and H, using the Pythagorean Theorem, what would it be? Good. X squared plus H squared is equal to B squared. How about if you were to write out the next one, the relationship between A, H, and C minus X? A little bit different. C minus X, that quantity squared, plus H squared is equal to A squared. So we've used the Pythagorean Theorem in both those situations accordingly. Excuse me. As you see this play out here, what do you notice that they both have in them? Oh, good. You see the X's. You also see the H's. Well, they both have an H squared, which is easier to access for this purpose. So I'm going to solve both for H squared. H squared is equal to B squared minus X squared. And on the other side, I have H squared is equal to A squared minus C minus X quantities squared. Now you say that if they're both equal to H squared, then they're both what? Yes, they're both equal to each other. So I could write B squared minus X squared equals A squared minus, now the C minus X squared, I want to actually work it out. To square C minus X, you need to do C minus X times C minus X. C times C is C squared. C times negative X is negative CX. I have another negative CX, so negative 2 CX's. And negative X times negative X is positive X squared. So that's what needs to go down here. And it's a minus sign. I distribute the negative sign all the way through, so it's a minus C squared. It's a plus 2CX. And it's a minus X squared. Well, this works out pretty quickly right here. And pretty nicely. If you notice, you can add an X squared to both sides. The X squareds go away. And you're left with an interesting formula here, which says b squared equals a squared minus c squared plus 2cx. Now, what that does for us is it states a relationship between all the sides using A, B, and C. So if we're given all sides of a triangle but not an angle, then we might be able to solve for it. And again, this is not a right triangle, so we're very close. All we need to do is get rid of this x. This x right here. We need to get rid of that. And so going back up here, it's a little trick. I'm going to use this section right here. Can you say something interesting about B, angle A, and angle X? Think about it. Say something interesting about angle A, side B, and side X. Hopefully you got it. The cosine of angle A is equal to X over B. So if I can solve for X, know what X is, up here, I can insert it down below. Well, if I just simply multiply both sides by B, I get B times the cosine of A is equal to X. Now I have no more X's, I have no more H's, I can plug that right in down there. And you get this new formula. B squared equals A squared minus C squared plus 2CB times the cosine of A. Get my recording out of there. And that's what you get. Now, you guys, that's one way to express this relationship, the law of cosines. B squared equals A squared minus C squared plus 2CB cosine of A. That's one way to do it. There's hundreds of ways to express those relationships. I know it looks really confusing, but it's not that bad at all. And you don't have to memorize it. I have it in your sheet of notes for you. If you look on your decision tree, if you're ever given a side, an angle and a side, so you would have no opposite side there, or all three sides, you can use the law of cosines in order to solve for it. And the law of cosines, there's a bunch of them sitting right here. There's 6 deviations of the law of cosine right here. The most common one would probably be, if you ever take another class, college class, it would be expressed as the one I just circled in blue. And that's one I'm going to write down. Now, you can always refer to this sheet. Use whichever of these 6 you want. We'll teach you how to use all of these. But I will always probably refer to C squared equals A squared plus B squared minus 2AB cosine of C. I know that looks a little bit different than what I came up with here. But it's really not. As you notice down here, I've got B squared is A squared minus C squared plus 2CB cosine of A. If we simply just add, subtract some things to the other sides, we're going to come up with the exact same piece. So if you flip your notes over, we'll just write that in here just for good measure. It says given ABC is a triangle with sides ABC, then we know this is true. C squared equals A squared plus B squared. Hey, that looks like Pythagorean Theorem. Except we have this minus 2AB cosine. Whoop. Capitalize that for good measure. Cosine of C. And there you have it. And notice how it works. It says must be given angle and 2 adjacent sides or all 3 sides. If you have an angle on its opposite side, then use the law of sines. If you don't, then use the law of cosines. So that will get us started. We'll do another video where we can actually try a couple examples, get you guys going here. But that's where we get the law of cosines.